Hey, hi everyone. OpenAI has recently released a multi-agent orchestration framework called Swarm. Basically, using this framework, we can create the multiple agents and we can orchestrate them. Orchestration is basically how does these agents are going to communicate with each other and how do they going to transfer control from from one agent to other agent, and that's what this Swarm is about. This seems very a simple framework compared to the LangChain LangGraph framework. So what we're gonna do in this video, we're gonna create some simple use case, okay, involving three agents, which is a kind of a real life scenario or real life use case. So at a Future Smart AI, we build the RAG or NL2SQL solution for many clients, and many of them has a requirement that our chatbot should be able to answer from both the sources, the documents they got and the database they have. And basically there should be a central logic which decides whether the given user query needs to pass through a document or a vector database or it needs to go to the database, and there could be one more source and calling an internal or external API or something like that, right? So we will have these simple applications that we will try to create or orchestrate using this OpenAI Swarm. Okay, so first thing we need to download this framework. So let's download this. We use the pip install and we also set our OpenAI key, because the agent here is basically an LLM. In our case, it will be an OpenAI LLM. So we're gonna use that LLM. So okay, I think it got installed. So there are two simple concepts that we need to understand in this Swarm OpenAI framework. The one is creating the agent, the other is handoff. How does these agents transfer control to other agent? Basically, handoff is the concept where one agent can transfer to the other agent. Now let's see how do we declare an agent. So first of all, let's say we import the agent and the Swarm. Let's look at the agent. Sorry. To declare an agent, we use this agent constructor. We give name to this agent. Let's say we are saying, you are a weather agent, and we also give an instruction or a prompt to this agent. We are telling you handle a weather related queries, and if you have any other queries, transfer to the other agents. And we also give it one function, which is the handoff function. You can see this function can transfer task to the math agent. So this what we call in Python, right? Whatever this particular thing, this get converted into the description for this particular function when this agents get created. So we are attaching one function called handoff to the math agent, which tells this weather agent that you can transfer task to the math agent. That's called the handoff, giving a function or a mechanism so that this particular agent can transfer control to the other agent. Similar way, we declare the math agent. We tell it that you only answer the mathematical queries, and for other queries, you transfer to the other agents. And we also give it a handoff function which will return the weather agent. And it also has a description that this function should be used if this agent wants to transfer control to the weather agent. Okay, so this way we can declare agents, and we can also give them a function so that they can transfer control to the other agents. Now let's create this Swarm client or orchestration. So we declare or we create the Swarm client. Did we run above cell? Let's run this cell. Now let's create this Swarm client. And what we could do, we can give an entry point for this application. So whenever we have this Swarm client, we can run this client with giving an entry agent or entry point. So here we are giving an entry point as a math agent, that we are saying we should start with the math agent. Means what? Whenever we are passing our query. Now these Swarm agents take input query in the form of messages, because these are the chat models. It take the messages. So when we pass these messages to this Swarm client, it transfer this to this first agent, what we declare, which is a math agent. And this is how we are passing those messages. So we are calling here Swarm with the math agent, and let's see what happens. Okay, you can see when we call with the math agent, but we ask a question related to the weather, it has handed off, for like, let's say it has passed control to the weather agent. This is what this is how it able to pass control, because it knows that it should only answer the mathematical queries. For others, it needs to transfer to the other agent, and it has transferred to, let's say, this weather agent. And here, this is what the response we got. Let's say currently there is no function there so that it can get the actual weather, but what is important here, that it has transfer control to the weather agent. What if it was a mathematical function? Then what would happen? Let's see. If it was only mathematical, then it has directly given answer without transferring the weather agent. Similarly, we can also test, if you start your Swarm application at the starting point with the weather agent and ask the math question, it should transfer that thing to the math agent. You can see it has transferred to the math agent. And when you get this response, it comes with a lot of this information. The response comes with the messages and all those things, but we know we only care about the last message of that response, and we want to print the content of that last message, which is this answer. We can also see this response as a property called agent.name, which tells that what is the last agent which answered this thing. So this was answered by the math agent because it was the math question. Now we could try the same thing, and this time it should not transfer to the math agent. Not sure why it is taking time. Okay, basically it come up with all this India's weather information, try to answer it, but we could see here it didn't transfer the math agent, and we could also confirm whether the agent that is answered the last part is the weather agent and not the math agent. Okay, so this is very easy. We just saw how do we create the what I say, where is this? Yes, how do we create those agents using this simple constructor, and how do we specify the tools or the functions those weather has, and how do they can transfer control from this one agent to the other agent. Now let's look at some real life example. Okay, here I show you that we're going to use this RAG agent, NL2SQL agent. See, RAG itself is a big concept. If I start creating the RAG agent from the scratch and start explaining you, this video is going to be very long. Similar with the NL2SQL agent. But I have already created a dedicated video. So there is a dedicated video for the how to create the RAG application end to end, and how to create the natural language to SQL. This has all the scenarios what I came across at a Future Smart AI when we build solutions for our clients. So I try to summarize or try to mention all of them here. Now what we're gonna do, we're gonna create those things. Maybe I'm not gonna explain every line code of this particular tools. If you want to know more about them, you can go and watch these individual videos, and then you can understand how to create the RAG or how to create the NL2SQL. Here, my focus will be on orchestration. My focus will be on the OpenAI Swarm. So let's first create the RAG tool. To create the RAG tool, we're going to require, so what I'm going to build my RAG tool using the LangChain. Okay, this is also interesting that how we could use LangChain within the OpenAI Swarm, because OpenAI Swarm is agnostic of any what we are using under the hood, right? So we could create tool or the logic, because ultimately what it only cares about calling a simple Python function. Now that Python function can represent any logic, and that is the beauty of any framework. I think even LangGraph, you can create the LangGraph agent without LangChain, because those agents just require a function that you could call. Now let me quickly show you how we created the this RAG application. So the first thing is we have a utility to load our documents. So I got some couple of documents here that we could load using this particular function. Okay, so we are using this PyPDF loader and the doctxt loader from the LangChain document loaders, and we have, so you could see that we have load all of these documents here. Maybe I just clear out. Okay, now next what, we have loaded the documents. If you're not familiar, let me quickly show you. Let's say if I search the LangChain RAG, then I should see that I want that image. Okay, so basically, we need to first load our document, then split this document, embed and store. This is the process we need to do for our RAG, and that's what we are doing here. We have loaded our documents. Now we could, split those documents using the one of the text splitter that LangChain provides, and this will simply split our documents. Now, once we got this smaller document, we require a vector database so that we can store. So I'm going to use the ChromaDB for the vector database, and for the embedding, we're going to use the sentence transformer embedding. Again, it's getting very fast, or I'm not explaining all the things because it's not possible to explain this thing in this video. Go and check this LangChain RAG code so that you understand everything what I'm doing here. And here, let's create our vector database. So I'm creating one collection, and all the documents that we saw on the top, which are splits that we did using our text splitter, which is this, I'm storing those documents inside the vector database. Okay, I think vector database is getting created. We will be using this particular sentence transformer embedding. I think it's downloading that transformer model for that embedding purpose. Okay, this has downloaded this thing. Once this finishes, we should see our this vector database is getting created. So it has created vector database at this ChromaDB1, and we can confirm it is created. Yes, there is one folder called ChromaDB1. So it has cleared this. So let me clear. Now we got a vector database where we have insert our document. Let's confirm whether this semantic search is working. So I got some document where related to this company called Green Grow, and it has information when it was founded, and I want to make sure this vector database which is created, this one is actually capable of answering or not answering. It will not able to answer, but to find the relevant document, so that we know that our tool is working. So it has found one document, and this is where it has written founded in something. So basically it is able to find the relevant documents. Now we can create our tool, which is nothing but the RAG tool, because currently we have only retriever. We need an LLM which will answer the question. So we declare one function called retrieve and generate. This will take our query, and then it will have access to our context, and then basically it will try to answer based on that particular context, and that context it will get from retriever when we call the query. So let's do this thing. So we declare our prompt here, which is typical RAG prompt, which has the context and question, and here is our RAG chain using the lang chain, which I have explained in that my RAG course. So in short, what is happening here, whenever we ask any question, that question get assigned to directly this question variable. So it's like one-to-one mapping. Then this question goes to retriever. It retrieve the relevant documents. We clean those documents. Basically, we take only the page content field associated with the document, because it has a lot of metadata, but we only care about the page content. So we take that page content, and we get the clean context and the question. Then it goes to the prompt here, and then finally this prompt goes to LLM, which we have declared GPT-4o Mini, and this GPT-4o Mini produces the output in the form of, let's say, what I call the AI message. We transfer into the we convert into the normal string message. So let me show you. Earlier we only got the relevant document, but now we want to get the answer back. So this is what the RAG chain. So we got one tool. So basically now we got a RAG tool which is available. Now we need to build an NL2SQL tool which can take the query and give us the SQL query back. Now this tool is working. This tool is nothing but this Python function which is able to do all this RAG thing. Now for the database, we're gonna use this popular data set. Database that you can find this even on the LangChain. So let me see this data set. If you go here, I thought it might be here somewhere. Database, data sources, this one. Yes. So it has this artist, it has this genre, track, some kind of a music, and their customer, their invoicing, and all these details what we have. So simple database that we could use, and that's what we are doing here. So we downloaded that database, and we are using this LangChain SQL database kind of a chain. So we got the DB instance. Now I have declared one function here. Sometimes I have observed that this SQL generation generate query like this. This is an SQL query, but it generate with the markdown syntax. So I need to clean this thing. So that's why this function is called the clean SQL query. If the generated query has the markdown, it will remove this thing, and you can check here. This is, many people struggle with this, that when they don't get the syntactically correct SQL query. Now let's look at we have a simple SQL prompt which is saying that you are an SQL expert. You will get the table info detail, basically all the tables and their column names, and how many rows to select, kind of a simple prompt. Again, you can watch this tutorial called NL2SQL. Here I just want to build that particular tool. So here I'm declaring that prompt, and this is where I'm not using now this clean SQL. I have above function. This is the chain. Now let's run this chain. Okay, we are asking how many customers are there, and it has answered there are 59 customers there. Let's see what has all happened. So here is the function or the tool we're gonna use called SQL response generation. It takes our query, okay, and then before it goes here, let's say we are creating a query SQL database tool using which we can execute any query. So this part is responsible for executing query. This part is responsible for creating an SQL query. So we give an LLM, we give our database connection, and we give our prompt. So we have our prompt here. This we can give, and this is a LangChain pre-built chain called create SQL query chain, which can generate the query. So we can generate the query, we can now execute the query. But once we get the data output SQL result back, we want to rephrase that for the user, and that's where this rephrase or answering prompt, which take the original question, the SQL query, the data that we got from the SQL, and eventually it rephrases, and we pass that prompt, rephrase prompt, to the LLM, and then finally the string output parser. So this whole things give us the what I call the NL2SQL tool. Again, all covered in this particular video. Let me see whether Langsmith has recorded this one. I don't know. I think there's something's problem. But anyway, we have earlier run that. We can check what I was saying. So this is the first prompt which take your all table info and generate the SQL query. You can see we got the generated SQL, and this is a markdown syntax. So we got the generated SQL query here. Then we go to our clean SQL query function that we have written. It will take this markdown syntax and it has clean it. And then next, this clean SQL query will go to the SQL DB query execution. It goes to the execution. We got this database result called 59. You can see this list with the tuple called 59, and then this database result go to the final rephrase of the answer. So we are saying this is our query, this is our question, this is the query, and this is the result. Can you rephrase it in a nice way? So it is saying there are 59 customers. So this is the whole so this is an AI message gets converted into the normal string using this parser. This was our SQL tool. Now we got both the tools. We got the RAG tool. Now we got the NL2SQL tool. Now let's create this agent. We will create the RAG agent, NL2SQL agent, and this central agent with the same syntax what we saw earlier. Okay. So we declared a agent called the name is a RAG agent. We say that you retrieve relevant information from the company's knowledge base. There is no company knowledge base. Let's say I would say only knowledge base, and generate the response to general queries about the company. Again, not needed to specify anything about the company or anything. Maybe I was testing a different document, and we say for this agent that you handle the database related queries, and for the RAG agent we have given a function that retrieve an agent. This is the function which the tool we created on the above retrieve and generate, which can give response from the documents. And similarly, the NL2SQL agent has access to the function called SQL response generation, which is this above function, which can generate the response. Now, both of these agent has a capability that they can pass, argument to this particular function. So let's declare these two agents. Now let's declare our central agent. We call our central agent that determine if the query is related to the RAG or query is related to the database and route it accordingly. That's the thing. And the central agent, what we got here, we can attach functions to this central agent. So we have given two functions, how to transfer to the NL2SQL and how to transfer to the RAG. And again, this represent the description of this particular function. So it knows that to transfer to the NL2SQL, call this function, and it will return that NL2SQL. Similarly, for general queries, let's say for general queries, pass it here. Now let's run this. Now let's test it. So we got the Swarm client, right? And we will run this client at the starting point a central agent. Now central agent has access to both these agent because it knows how to transfer control. Now let's see what's happening. Did we have any print statement? Yes, we have added a print statement. Now I'm asking? So I'm asking some question related to the general information or document. Let's see what happens. Okay, it is saying it is handing off to the RAG agent, and the RAG agent has answered using its function. To make sure, let me go back here, that RAG agent is also calling this function or not, right? So let's add a print statement here so that we know that it has called this function. Okay, calling retrieve and generate. Let's say we're gonna call this one. And similarly here also we will add some statements so that we know that it has called this function. Calling SQL response generation. Okay. Now let's try again running. Same thing to see what's happening. Alright, we didn't see this calling. Maybe we have to declare this thing again. Okay, maybe we haven't declared this thing. We have to declare this thing again. Wait a minute. So when we call this function, let's make sure that this agent has access to the new function that what we have declared. And let's do this thing. And now let's try. Yes, now it is working because it didn't have access to the latest functions. So when we ask central agent about some generic RAG related query or general informational query, it has decided to handing off to the RAG agent. And then we could see the RAG agent has called the retrieve and generate function, and finally we got the answer. And we could even check if I ask something like how many employees are there, and let's see what happens. This time it has decided to call the NL2SQL agent, and we can see NL2SQL agent has called the SQL response generation function, and we got the answer, right? So this is amazing. Actually, we could easily create a very simple agentic flow where you got the multiple agent. They can have actually multiple tools. Currently we have only one tool. Imagine a scenario that this agent should also know how do we call the other agent, and this communication. But as I said, I wanted to keep this use case simple but useful. Like this is the typical thing we do, and I would definitely say this Swarm, the way we created the agent, it is very intuitive and simple compared to the other agentic framework what we have, right? And this is a new framework, this Swarm AI, but hopefully it gets mature and it brings more simplicity into multi-agent orchestration thing, right? So I hope you find this video useful. Again, just keep this thing in mind. My focus was not explaining the RAG agent or explaining the NL2SQL agent, rather having a real agent created quickly so that you could see how central agent can communicate with those real agent, right? And don't forget to watch this RAG video and the NL2SQL video, else you might get frustrated that you didn't get what I was talking about. Again, I will be sharing this notebook in the description. So usually you will have our blog link, and then you can go back to our blog, which has this notebook and also some explanation regarding this, or if any correction I want to do, I will be making this correction there. Okay, thank you very much. If you have any suggestions for me, or if you have any suggestions for the next video, you can comment and let me know. Thank you.